Welcome to MSBT online learning platform. We bring you the most relevant content in an exciting digital format. Today we will be studying a very interesting module from applied mathematics, that is differential calculus, which includes topic derivatives 1, where we will be studying some interesting facts about the derivatives and we will be practicing some of the examples based on it. So let us begin it. Dear students, I welcome all of you. Today module is differential calculus and topic is derivative 1. Under derivative 1 we are going to learn the basic concept of derivatives. Interpret the limit definition of the derivatives of a function y is equal to fx at a point x is equal to a. Second objectives. You must be able to solve the examples on rules of derivatives for simple functions. Understand the idea of differentiation from first principle. Differentiate different types of real valued functions. Solving examples on derivatives of different functions. Dear students, now we are going to study the derivative. Now there is a question in your mind and my mind, why we should study the derivative? Yes. Derivative is required in all walk of life. For all the actions what we are taking in the life, derivative is required. Now you see one example. The car is moving on the road. If you minutely observe the motion of the car at all the turning points, the speed of the exterior wheel of the car must be more than the speed of inner wheel. Otherwise, there is all chances of accident. How this ratio of speed of outer wheel and inner wheel is maintained? Not only the speed of outer wheel be more than the inner wheel, but it must be in certain fixed ratio. That ratio is controlled by one device fitted with the gear. And that device is designed with the help of the derivatives. You see the use of the derivative, how much important it is for our life. Now you see another example. This is satellite, we know that. This is our car at this point, and this is the road. You see the way of the road, and this is the destination. If we don't know the route, we don't know the destination, even then, by using the GPS system, we can easily reach to our destination. You know what is GPS system? It is global positioning system. How it works? The satellite is known as eagle's eye. From the sky, it is looking at all the things. It is observing our car, route of the road, destination. As we start, it is observing displacement, time required to reach the destination, and the distance of the destination. All these value is known to the satellite. And with the help of this GPS system, we can easily know the time required to reach the destination, speed of the car, and all these things. What is this? This is nothing but the ratio of two different values. And this ratio of two values are known as derivative. That's why this satellite is working on derivatives only. These are the live examples for the use of the derivatives. Now you see, interpretation of definition of limit for derivatives. In fact, differentiation is nothing but ratio of two different entity. It is also change in one entity regard to another entity. Now there is a question, what is entity? Anything which has their separate existence independently is known as entity. Just for example, I am is one entity, you all are different entity. That's why in case of mathematics we used to choose x and y as a entity normally. Now we are going to define, for the basic concept of differentiation, what is average ratio. Suppose A and B are two distinct points. A car starts from the point A, it travels 500 km and reaches at the point B after 10 hours. Then the average speed of the car is, we know, distance upon time, that is 500 upon 10, that is 50 km per hour. Now you see the second situation. The same car is starting from the point A. You see what happened. There is an accident of car at any point. For all practical purpose, for all investigation, we have to find the speed of the car at the time of the accident. That is instantaneous speed at the time of the accident. Suppose for the shortest distance covered at the time of the accident and the shortest time taken at the time of the accident is delta x and delta t, then instantaneous speed at the time of the accident is delta x upon delta t. As t tends to 0, limit delta t upon dx upon delta x upon delta t is equal to dx upon dt. You see, geometrical representation of dy upon dx. Geometrical representation of dy upon dx is nothing but the mathematical representation. Let us consider y is equal to fx is a real valued function. What is function? Any mathematical expression is known as function. All the mathematical expression other than linear represent a curve. That's why we are representing the function y is equal to fx through a curve, and a and b are two distinct points on the curve. These are the adjacent point, close point, and the coordinate of the point a and b are a, fa, a plus h, fa plus h. Now you see again, this is a curve. A and B are two distinct points on it. AL and BM are perpendicular on x-axis. A is perpendicular on BM. Theta is the angle between BAE. Therefore, it is clear from the diagram, A is equal to A plus H minus X. You see, it is clear from the diagram, A is perpendicular on OX, BM is perpendicular on OX, A is perpendicular on BM. Therefore, A is equal to A plus H minus A, that is H. B is equal to FA plus H minus FA. Angle BA is equal to theta. Therefore, slope of the line AB, that is tan theta, is equal to B upon A. Here you see, we are substituting the value of B and A, that is FA plus H minus FA upon H. As B tends to A, means B come close to, very close to A, then obviously the value of H would be 0 and theta will become theta 1. Therefore, as limit theta tends to theta 1, tan theta is equal to limit h tends to 0, fa plus h minus fa upon h is equal to tan theta is equal to dy upon dx is equal to limit h tends to 0, fa plus h minus fa upon h. Means dy upon dx at any point on the curve is nothing but slope of the curve at that point. Case 1, when y is equal to fa, that means the value of y is constant, then we will get a straight line which is parallel to x-axis. Therefore, dy upon dx is equal to change in y upon change in x. You see, y is constant, thereby there is no change in y. Therefore, change in y is equal to 0 upon change in x, which is 0. That means slope of the line parallel to x-axis is always 0. Case 2, when x is equal to fa, then the value of x is constant, we will get a straight line which is parallel to y-axis. Now the slope is equal to dy upon dx, change in y upon change in x. There is no change in x because it is constant. That's why change in y upon 0, which is undefined. Therefore, slope of the line parallel to y-axis is not defined. Now we have come to the conclusion dy upon dx is equal to limit h tends to 0 fa plus h minus fa upon h. That is known as derivative by first principle. And we have also seen the conditions when y is equal to fa and x is equal to fa. Now, using these concepts, we will solve few problems to make you understand. Now, I am calling Kale sir, Professor Kale sir, to solve few problems by this method, which is known as first principle, to make you understand and boost up your confidence.
Thank you, Haq sir. So, dear students, Haq sir explained the concept of derivatives in very simple way. So, now here we have to find out the derivatives of some simple functions by using first principle of derivative. Now we know what is a function. Function is nothing but y equal to fx. So here first we see what is our function fx. So y equal to fx equal to x. So students, see here the meaning of y is nothing but fx or fx is nothing but y. So we write down here y is equal to fx equal to x. Now for application of first principle of derivatives, we have to take small increment h in x. So how we take? We take f of x plus h is equal to x plus h. So here the small increment h in x. Now we put down the values f of x plus h and fx in the first principle of derivatives. So see here, limit h tends to 0, f of x plus h minus fx upon h. This is called first principle of derivative. Now when we substitute the values of f of x plus h and fx, we get the following expression, limit h tends to 0, x plus h minus x upon h. After calculation, x is getting cancelled and we get h upon h. So students, remember here, first you cancel h upon h. If you directly substitute h equal to 0 there, then we get the indeterminate form 0 by 0, and in limit, you already studied, 0 upon 0 is not equal to 0. 0 upon 0 is called indeterminate form, like infinity by infinity. These forms are not defined. So therefore, first you cancel out h and then you write down the values. So see here, what is the derivative of x? Derivative of x is 1. Now take another example on derivatives. Find derivatives of function y equal to x square using first principle of derivative. So just like a previous example, first we have to see what is our fx. Our fx is x square, correct. So now we have to taking f of x plus h by taking a small increment h in fx. So what we get here, f of x plus h? F of x plus h is equal to x plus h whole square, not x square plus h. So students, take care, when you take the increment h, you take increment only in x. If you write x square plus h, then it is wrong. You write x plus h whole square. Now, when we substitute all these values in the first principle, then our expression becomes limit h tends to 0, x plus h whole square minus x square upon h. Now, here we apply the two formulas. Either you apply a plus b whole square or you apply a square minus b square. So, we apply here a plus b whole square. Now, what is that formula? Tell me anyone, what is a plus b whole square? Correct. A square plus twice ab plus b square. Now, x is nothing but our a and h is nothing but our b. Okay. So the formula, after application of this formula, here we get a square plus twice ab plus b square, that means x square plus twice xh plus h square minus x square upon h. Now when we cancel x square, we get the expression limit h tends to 0 2xh plus h square upon h. Now student, here you take h common. You can't cancel h here and here or here and here. So remember, when two terms contain h, but when the sign addition or negative sign in between the two terms, you can't cancel out h from numerator and denominator. So first you take h common, after then you cancel out the terms. Now we substitute h equal to 0 in the above expression. So we get the derivative of x square is 2x. Now you got the idea how you find out the derivative of x square? By using first principle of derivative. Now by taking the same result, I am find out the derivative of x raised to n. So how? Let's see here. Now I am writing the same result. D by dx of x square is equal to 2 into x raised to 1. Because if index is not there, you have to imagine it is 1. So 2 into x raised to 1. So we write down this one like this way. 2 into x raised to 2 minus 1. Instead of 1, we write down 2 minus 1. Now if we substitute n instead of 2, now what we get here? So we get d by dx of x raised to n is equal to n into x raised to n minus 1. What is here n? N is a real number. Whether it is negative, positive, fraction, for any n you have to use the same formula. For example, let's we take some examples. Derivative of x raised to 10. What is derivative of x raised to 10? Now instead of n, you substitute 10. So 10 into x raised to 10 minus 1, that means you will get 10 into x raised to 9. Now I am asking you the another question for you. Now tell me, what is the derivative of x raised to 100? You tell me. Correct. Now instead of n, we substitute 100. So see, 100 x raised to 100 minus 1. So what we get? 100 into x raised to 99. Correct. Take another example. X raised to minus 2. Now we take negative number as an index. So apply the formula. Now you tell me, what is the derivative of x raised to minus 2? Correct. Minus 2 x raised to minus 2 minus 1. That means we get minus 2 x raised to minus 3. Very correct. So in such a way, we have to find out the derivative of x raised to half. Now we take another example for first principle of derivatives. Here I am taking the function y is equal to e raised to x. Now you already know what we want for first principle of derivative. We want fx, f of x plus h. Now we put down the values in the first principle and we find out the derivative of e raised to x. Now anyone you tell me what is fx here? Correct. Our fx is e raised to x. Now we take a small increment in x. So we get f of x plus h is equal to e raised to x plus h. Now by using first principle of derivatives, what is the first principle of derivatives? Limit h tends to 0, f of x plus h minus fx upon h. Now put down the values of f of x plus h and fx. So what we get? E raised to x plus h minus e raised to x upon h. Very good. Now by using the laws of indices, so all of you know what is the laws of indices. Which one laws of indices we have to use here? Anybody tell me? Very good. We have to say when the index is in the form of addition or subtraction, you have to separate the index with the base. Very good. So here we separate e raised to x into e raised to h. The meaning of e raised to x plus h and the meaning of e raised to x into a raised to h is same, minus e raised to x. Now what we do? दोनों टर्म में कुछ कॉमन है? Very good. E raised to x is the common term. So according to the mathematical rule, if any term is common between the two terms, then you have to take it outside. So here we take e raised to x outside. You have to take it outside directly limit. Is it right or wrong? Yes, it is right. Why we take e raised to x out of limit? Because we have to put the terms inside the limit, only those terms which contain h. Here h tends to 0. What is the meaning of h tends to 0? That means h is our variable. H is going very close to 0, but it is not exactly 0. H is very near to 0. That means h is changing. That's why we say that h is our variable here, and we have to take that expression which contain only h inside the limits, and that's why e raised to x as a constant we have to take it outside the limit. Now by using the rule of limit, we write down limit x tends to 0, e raised to x minus 1 upon x is equal to log e, and we know that the value of log e is 1. So finally what is the derivative of e raised to x? The derivative of e raised to x is equal to e raised to x. Now similarly, we have to find out some rules of derivative of different function by using first principle of derivative. Let's see. Derivative of x raised to n, derivative of e raised to x. Now, derivative of a raised to x. We know the derivative of e raised to x is e raised to x into log e, but the value of log e is 1, so that's why we write down only e raised to x. Now the same thing we use for derivative of a raised to x. Derivative of a raised to x into log a. Log a is not equal to a. It is a constant value, unknown value. So that's why we put a raised to x into log a as it is. Suppose we have to take a small example. Instead of a, if you have to put 5. So what is the derivative of 5 raised to x? Anybody tell me by using the same formula? Very good. If you have to take the derivative of 5 raised to x, then we use the formula of derivative of a raised to x. So derivative of a raised to x is a raised to x into log a. Similarly, derivative of 5 raised to x is 5 raised to x into log a. Very good. Now another derivative of log x is 1 upon x. Derivative of sin x is cos x. Derivative of cos x is sin x. Derivative of tan x is sec square x. Derivative of sec x is sec x into tan x. Derivative of cot x is minus cosec square x. Derivative of cosec x is minus cosec x into cot x. And now we have to see the derivative of inverse trigonometric function. Derivative of sin inverse x equal to 1 upon root of 1 minus x square. Derivative of cos inverse x is minus 1 upon root of 1 minus x square. Now see what is the difference in the derivative of sin inverse x and cos inverse x. It's a very small difference, and that difference is of minus sign. So students, you take care here. When you buy all these formulas, you try to develop some your own ideas how you remember these formulas. So you remember only the derivative of sin inverse x, you will get the derivative of cos inverse x by taking negative sign. So the derivative of another trigonometric functions, same thing like this way. The derivative of tan inverse x is 1 upon 1 plus x square. Then the derivative of cot inverse x is minus 1 upon 1 plus x square. The difference of only negative sign. Similarly, derivative of sec inverse x is 1 upon x into root of 1 minus x square. And the derivative of cosec inverse x is minus 1 upon x into root of 1 minus x square. So see this small change of negative sign, and you have to remember the derivative of all these inverse trigonometric functions. Now lastly, the derivative of constant is 0. Can anybody tell me why the derivative of constant is 0. Yes, very good. Constant. What is a constant? Constant means there is no change. In derivative, we want variations. Already Huck sir explained the first principle of derivatives f of x plus h minus fx. That means there is a variation. And that's why we get the first principle of derivatives. Now, in constant, there is no variation. That's why the derivative of constant is always equal to 0. What is a constant? Constant d by dx. That means जो टर्म में x नहीं है, we have to say that it is a constant. d by dx of sin y. Y is not variable here. d by dx of sin t. Here we have to differentiate with respect to x, but x is not there. That means we have to say that this is a constant and the derivative is always equal to 0. So, remember, if d by dx is there, then the term must be contain x, otherwise that term is constant term. Now, the rules of derivatives. If fx and gx be the two functions, then the first rule for addition and subtraction, d by dx of fx plus or minus d by dx of g of x. Now, this is for a number of terms. If f of x plus or minus g of x plus or minus z of x plus or minus t of x, you have to separate out the derivative for all the terms. Now, another rule. This is a very important rule in derivatives. It is a product rule. Now, just like a previous one, you can't separate only d by dx of fx into d by dx of gx. No, it is wrong. This is only for addition and subtraction. But for multiplication, this rule is totally different. So, what is that rule? Fx into derivative of gx plus, substitute plus, gx into derivative of fx. देखिए, प्रोडक्ट रूल है लेकिन बीच में प्लस साइन है. व्हाट इज दैट रूल? fx derivative of gx plus gx into derivative of fx. Now, how you remember this result? Simply, just I am putting instead of fx1, instead of gx2. Now, in your own language, you have to tell me how you write down this rule. Correct. First into derivative of second plus second into derivative of first. So, simple way you have to remember this product rule by using function 1 and 2. Now, the third rule is very important rule, division rule. When you consider the two functions in division form, then how you apply this derivative rule like, now see here, fx upon gx. Now, the rule is gx into derivative of fx minus fx into derivative of gx upon gx whole square. Now, you are little bit confused in between gx, fx, gx को ऊपर रखना है कि fx को ऊपर रखना है. So, अभी मैं आपका confusion दूर कर लेता हूँ. You have to remember the same formula in this manner. Numerator you have to write down nr. Denominator को हम लिखेंगे dr. So, we read this formula like this way. d by dx of numerator जो भी है रहने दो upon denominator जो भी है वो रहने दो. So, how you apply the formula? Denominator into derivative of numerator minus numerator into derivative of denominator upon square of the denominator. Students, remember, I have seen so many students made mistake at minus sign, positive sign. They confuse at the time of examination. This rule contains positive sign or negative sign. This rule starting with denominator or starting with numerator. So, see carefully, the formula is start with denominator. Denominator into derivative of numerator. In between there is a negative sign, not positive sign. Minus numerator into derivative of denominator upon square of the denominator. Now, examples on rules of derivatives for simple functions. So already we solved such type of examples. Derivative of x cube. Now you tell me what is the derivative of x cube. Good. dy by dx is equal to 3 into x raised to 3 minus 1, that means 3x square. Which one formula we have to use here? Very good. Derivative of x raised to n. We have to use this formula here. Our n is 3. So the derivative of x cube is 3 into x raised to 3 minus 1, that is 3x square. Very good. Take another example. d by dx of x raised to 10. We get 10 into x raised to 9. Similarly, we take another example. d by dx of root x. Now students, you tell me what is root x. Root x का तो derivative हमने देखा ही नहीं है. Then how you find out the derivative of root x? So my dear students, root x is nothing but x raised to half. Now, what is our n here? Our n is half. That means, which one formula we have to use here? Half into x raised to half minus 1. So we get finally half into x raised to minus half. Now we have to make this power positive, so that's why you keep x raised to half in denominator, or we write it is 1 upon 2 root x. So derivative of root x, you directly write down 1 upon 2 root x. Now another problem, third root of x. Now what is the derivative of third root of x? Now again you have to convert in the form of x raised to n. Now you tell me what is the third root of x? What is the index of x here? Very good. It is x raised to 1 by 3. So what is the derivative of x raised to 1 by 3? Again you write down 1 by 3 into x raised to 1 by 3 minus 1 by using the rule n into x raised to n minus 1. So after calculation, we will get the result 1 by 3 into x raised to minus 2 by 3. Very good. Now 1 upon root x. So now you tell me how you find out the derivative of 1 upon root x. अभी root x तो denominator में है. Then what is the process to take root x in the numerator? Very good. We write down first 1 upon x raised to half. Now we take x raised to half in numerator by taking negative index. So d by dx of x raised to minus half. Apply the formula of derivatives x raised to n into x raised to n minus 1. So we get minus half x raised to minus half minus 1. Now after taking LCM, what we get? Minus half x raised to minus 1 minus 2 upon 2. See, this is our LCM. आप LCM में भी गड़बड़ करते हो. So take care when you take the LCM here. So what is the final answer? Minus half x raised to minus 3 by 2. So this is a derivative of 1 upon root x. So students, do you have any question?
Yes, sir. I have one question. How to identify derivative of exponential function e raised to x and a raised to x?
Correct. So here we see the process to find out the derivative of e raised to x, a raised to x by using first principle of derivative is same. Now we already I already explained the derivative of e raised to x by using first principle of derivatives. The derivative of e raised to x is e raised to x into log e. So I already explained derivative of e raised to x is e raised to x into log e, but the value of log e is 1. So that's why we write down derivative of e raised to x is only e raised to x. Now for a raised to x, the derivative of a raised to x is a raised to x into log a. Log a is a constant value. We can't write it log a is 1. Log e is 1, but log a is not 1, so we keep log a as it is. So derivative of a raised to x is a raised to x into log a. So a raised to x just like 5 raised to x. Derivative of 5 raised to x, 5 raised to x into log 5. 10 raised to x, 10 raised to x into log of 10. 15 raised to x, 15 raised to x into log 15. So do you understand what is the difference in the derivative of e raised to x and a raised to x? Okay, thank you very much. Interpret the limit definition of the derivatives of a function fx at any point x equal to a. Second, able to solve the examples on rules of derivatives for simple functions. So what is the conclusion? Here we find thus derivative is a change in one variable with respect to another variable. Second conclusion, we use the concept of derivatives to find velocity, acceleration, etc. and in different walk of life for all practical purpose. Now you are fully competent to solve the problems of derivatives on rules of derivative. So worksheet is given below, try to solve it. So in the first example, every term contains x, but the last term does not contain x. So therefore it is a constant and the derivative of constant is 0. The other's derivative you know. The final answer is this. Now the second example, here we take the product of two different functions. So we have to apply product rule here. So x into derivative of e raised to x plus e raised to x into derivative of x. So final answer. In the third example, we have to apply the division rule. So what is the division rule? See here. Then derivative of log x is 1 upon x, cancel out x, and this is the final answer. Now in fourth example, e raised to log x plus e raised to 5. Now here we use the rule of logarithms. E raised to log x is x. So therefore we substitute x instead of e raised to log x. E raised to 5 is again constant because it does not contain x. Final answer. Now again here apply the product rule, x into tan inverse x. This is the final answer. Here apply division rule. See the calculations. Cancel out x, write down the final answer. Now 7th example, y equal to log x to the base 2 plus 2a raised to x. Now what is the important thing here? Log x to the base 2, you have to apply the change of base rule, log x upon log 2. And 2a raised to x is just like a raised to x. So finally, log 2 as a constant, you take it outside and write down the derivative of 2a raised to x. See the final answer. Now in this case, y is expressed in multiple of 3 functions. So how you apply the chain rule? E raised to x sec x, you take derivative of tan x first, plus keep e raised to x tan x as it is, derivative of sec x, plus keep sec x tan x as it is, derivative of e raised to x. So this is the final answer. Now here, apply division rule. Denominator, derivative of numerator, minus numerator, derivative of denominator upon square of the denominator. Derivative of e raised to x minus 1, derivative of e raised to x is e raised to x, derivative of 1 is 0. So take calculations, cancel out e raised to x, write down the final answer. Next topic, differential calculus, topic derivative 2. In derivative 2, we learned the derivative of composite functions and the related examples.
You have learned some important topics so far, and we hope you had good time learning with us. Browse through our online library for more content on the MSBT website. Thank you. Stay connected. Happy learning.